Welcome to the module. So now we are going to introduce to our another unit which is available in our lab, which is CDAC, which is called compact DAC. So the advantage of this DAC when compared to that particular device is that even it can perform the same, but much more advanced manner. It has better accuracy, better resolution and better sampling rate too. So that even a smaller signals that is required to be acquired can be acquired using this device. So this I am going to place it on our anti-vibration table. So here we can see both the devices. One is the previous device which I have explained you, virtual bench, and the compact DAC. I am going to place on my anti-vibration table. So this is an anti-vibration table, you can see, so that even any vibration it cannot affect of the system that is being measured. And on top of it you can see different channels, modules, those are called different varieties of modules which are available for the data acquisition unit itself. So we can see here one is analog input channel, so where it can be used for input current as well as input voltage too, and it has an onboard ADCs as well as amplifiers, everything, and this is for bridge kind of circuit. It can perform both half bridge and full bridge. So in case when we are dealing with force sensors or strain gauge based force measurement units, so since these are resistive type of sensors, one way is you require to convert your resistance change to a voltage output. So one way to do is either a half bridge connection or full bridge connection. So full bridge connection will always have very good sensitivity as well as very less linearity error when compared to that of your half bridge or something. So in order to construct that, so if we have a precise, if we have a very sensitive signal conditioning unit, so it gives you more accuracy on your measured voltages. So one way to do is if we have an onboard data acquisition with a onboard signal conditioning unit, it helps very good. So how to place in the sense? So if you see to the chassis, it contains different number of channels. So simply select the required signal conditioning unit, or they call it as a module, and place it on the appropriate channel. So the advantage is that it can be interchanged. It need not to be fixed only to that particular channel, even it can be fixed to the last channel anywhere, wherever it is required. So we also have analog output, say it can produce up to 20 milliamps of current, and it is a 16-bit analog output too. So even this you can use it in the same chassis itself, and all units can be performed at the same time. And other one is a quarter bridge analog unit. The difference between the previous module which I have showed to this module is by making use of the previous module, you can perform a quarter bridge, half bridge and a full bridge. But by using this module, we cannot perform half bridge as well as full bridge. This is only meant for quarter bridge applications. So even this I can place it on the module, on the chassis. Just simply plug and play, very easy to connect it. And this is another one which I already told you, it is analog input, either voltage as well as current can be taken as an input to this system. So even this I am connecting it here. Now once I plug in, so if I want to visualize and if I want to acquire the data in a PC, so what we have to do is that, so since it is a compact DAC, it should always be connected to a PC. One way of connection is either directly connecting the LAN connection to the PC, or if it can connect to the same network. If it can connect to the same network, the purpose can be served. So now I am powering it up. So we can see here the power has been powered up and it is connected using a LAN. Right. So what I do is that I will take few wires by using this virtual bench. I will connect it to the DC power supply, and if I vary the signals from the DC power supply, we can observe the signals being being acquired using this CDAC in our monitor. So, signals can be generated using PC from the virtual bench, and the same signals can be acquired using another compact DAC and can be acquired into this data acquisition device to the PC using this data acquisition device, and even that we can visualize. In between there is another software called LabVIEW. So, what we can do is that whatever the data that is being acquired using this particular device, that can be acquired using that device and can be done a further processing using that device, or if I want to make use of the same device for controlling, even we can do that. So, now what I will do is that in order to understand ourselves, so I will connect a power supply unit to this. And this is a positive. So, what I am doing is I am unplugging this device. So, here if I see AI 0 plus and 0 minus. So, the first channel. So, here if you see there is different number of channels starting from 0 to 7. So, total it has 8 channels for analog acquisition, which can measure up to plus or minus 10 volts. So, it has both positive terminal and negative terminal. What it does is that it can measure a differential input. Some cases where when you are using a quarter bridge or when you are using a half bridge or full bridge, whatever the voltage signal it is being generated from the bridge signals are not a independent voltage, it is a differential output voltage. So, if I want to make use of a differential input, one way to do is that we have to make use of this device. So, what I do is that I will connect, this is some kind of a spring connection. So, to the first channel, it need not to be only to the first channel, it can be connected to any channel. So, right now I am connecting to the first channel. So, since it is a spring device, I have to press it and place this. Connect it, then to the negative, so I will pressing it, I will connect it. So, now we see how do we connect our negative. So, since it is also a spring, so I am pressing it, I am placing it into the hole, removing it. So, now it is connected. Once it is connected, I am placing it into the chassis. So, the number is just 9207, whatever I am using is 9207. Right. So, from the hardware point of view, we have done all the necessary connections required to acquire the data using the CDAC and to generate the data using voltage signals using this voltage source from the workbench. Now, how do we acquire, how do we visualize the signal in the software, that we will see that. So, last time we have already seen how to generate a data using National Instruments workbench. Now, we will see the generation in the software and acquisition using this level. So, once we finish our hardware connection, so now we will look into the software. So, first step is generation of voltage signal. So, to generate that, first I have to open the virtual bench software, which we have seen in the last time. So, right now it is being connected using Wi-Fi device that we can see here, and I am going to virtual bench software, start NIMAX. This is for CDAC, just to test the device has been connected and whether it is working or not. So, here we can see, since it is connected using a LAN in a server, here we can see what are all devices is being, NI devices is being connected in a MAX, and here if I click on to the network devices, we can see the device name which is connected, NI CDAC 9189. So, on top of it, if I refresh it, what are all the channels is being connected can be tested it here, can be seen here. So, here we can see the device under the network devices, we can see what are all devices is being connected. on the same chassis what are all different modules are being connected. So, right now we are making use of the module 4 which is connected at the 4th channel, which is NI9207, which is being connected to that. So, if I go to the test panels here to just test whether the module is working or not. So, we can make use of the test panels and we can work through. So, I will go through the continuous acquisition, and the channel whatever I being connected is was AI0. So, I am selecting AI0 channel, and the samples to read is 10 samples and the sampling rate is 20 Hz if I say. What I will do is that from the virtual bench software which we have seen last time, since I have connected a DC power supply of 0 to 6 volts to an input to this particular module NI9207. So, here I will be switching on this module. So, right now I am applying 0 to 1 volt. In the test panels, if I start it, so when we see here, so the input voltage being applied is 1 volt, we can easily see in the test panels. I changed to 2 volts, changed 3 volts. But why it is slow? Because the sampling rate whatever I used is of 2 Hz. Suppose if I make it as some 1 kilo. So, we can see very fast change in the input voltage too. So, the maximum is 6 volts, 6 volts. So, this is the one way to check whether the test panels, or to check whether the particular device is being acquired or whether the device is working or not by using the test panels. But if I want to do some further processing, you cannot do any further processing using this particular test panels. So, how to do? In the sense, we have to write a program or write an algorithm in a LabVIEW software. So, I can open LabVIEW. So, once we open it, so this is how the LabVIEW one looks like. So, new VI. So, here we can acquire the data using measurement IO, or we can go to Express and I can make use of single input data assist. Acquire signals, analog input voltage by using module 4 AI0. This is where we have connected to 9207, just finish it. After this, so how many number of samples that we need, or I can make it as continuous samples, then samples to read rate is of 10K or 1K we can keep, and the samples to read I am making it as 100 samples to read. Yes. So, the data whichever is being acquired, I will be displaying it on the front panel by using a meter or some gauges. So, I am connecting it to the gauge. This is a gauge and connecting to the data. So, if I run the PC system, so let me switch off. I will enable digital display to this too, digital display, so that easy to visualize the digital data, and I am switching it on. Once it switches on, we can see three volts, 2, 1, right. So, whatever the data that is required, we can acquire using this particular software, and using this software with the different functionalities that are available with this software, like different loopings that we want to do, array functionalities, numeric, any other applications like control, logical and actuation of something, everything can be implemented here, and again we can give it back to any plant. So this is how this can be useful for acquiring as well as monitoring or acquisition of the signals from a sensor and to do the processing using that. Thank you.